Hello and welcome to the second in our series of Analytical Insights videos, where we bring you advice on the importance of carrying out bump testing on portable gas detection units. We will hear from experts from across the gas detection industry, including those working closely with the regulatory industry bodies, a major manufacturer of detectors, a gas supplier, and then finally from an end user. I hope you find the video interesting and informative, showing why regular bump testing keeps us, our employees, colleagues and the public safe whilst being compliant to the various regulations that are currently in place.
At JMS Consultants, we've been delivering training in testing hazardous atmospheres worldwide for the last 30 years. It's very important for us and our clients that we have the most up-to-date information on regulations and standards, so we can maintain the integrity of the information we're conveying. We maintain membership with COGDEM, who are the Council for Gas Detection and Environmental Monitoring. Our membership of this group allows us to understand the collective views of member companies, many of whom are responsible for the manufacture of detection instruments. Our membership also allows us to assist in the preparation of acceptable British, European and international codes and standards. So what is bump testing? Bump testing is the application of standard test gas to a detection instrument to verify the functionality of sensors and alarms, not its accuracy. In previous years, the reasons for this may have been difficult to understand. In addition, misleading information about the so-called maintenance-free instruments led to a misplaced sense of security. If we consider that the output of a typical sensor in clean air is 0, this is the same as the output of a non-functional sensor. So exposing the instrument and sensors to gas is the only way to know that it will respond to a hazardous gas that may be present in the atmosphere. What are the relevant standards and regulations? In the United Kingdom, we have the Health and Safety at Work Act and other standards issued by the IEC, the International Electrotechnical Committee. Back in 2009, a performance standard and associated guidance document was published by the IEC, relating to the performance requirements of detectors for flammable gases. It became a harmonised standard under the ATEX directive on the 1st of November 2010. The document specifies the requirements for construction, testing and performance, and also describes the test methods that apply to portable, transportable and fixed apparatus for the detection and measurement of flammable gases and vapours in air. Now, the standard states that the manufacturer's instructions shall include the requirement and method for performing a functional check with gas before each day of use, the bump test. The legal implications then? Well, as the end user, you can decide to follow or not the standard and guidance document. But if you don't follow the manufacturer's instructions and there was a subsequent incident, you would almost certainly have to explain why you didn't follow best practice by adhering to the manufacturer's guidance. The Health and Safety at Work Act tells us what we must do and how this would appear to reinforce bump testing as a legal requirement. While your employer is responsible for health and safety, there are things that you must do to help. One of these is that you must follow the training you've received when using any work items your employer has given you. When training is delivered, we will highlight the need for bump testing in accordance with the IEC standard and the manufacturer's instructions. If you then take the decision not to follow the training you've received, you would not be following the important message relating to the key health and safety at work statement. So what about the rest of the world? There are many European and international regulations that follow the same theme. If you're outside Europe, you'll almost certainly find that your country subscribes to these key health and safety measures. Data in the public domain shows that on any given day, 1 in every 2,500 untested instruments will fail to respond to a dangerous concentration of gas. Sensor performance can degrade, and in some cases sensors may fail in an unrevealed mode or fail to danger. A competent person, responsible for testing and recording the results of atmosphere tests, has the responsibility for completing this task with all due diligence. Using an instrument that may not be fully functional potentially puts any operation in jeopardy. The risks to personnel are obvious, but potential damage to plant and equipment, adverse effects on the environment, and finally damage to a company's reputation cannot be ignored. Remember, bump testing saves lives.
What is bump testing? It is simply an instrument function test where the gas is passed over a sensor or sensors at a known concentration with sufficient exposure time to activate all the instrument gas detected alarm features. A bump test is a verification of the functionality of the instrument and not its accuracy. A bump test does not calibrate the sensors. Why is it required? A bump test verifies the performance of the gas detected and ensures that the sensor or sensors are responding to the target gases. Sensors can appear to be operating correctly by pressing the known standard electronic warm-up test and can display zero gas, excluding oxygen and CO2 sensors. However, certain sensors can be poisoned or inhibited, hence they are not fail-safe. Applying gas to a sensor is the only method to ensure that the sensor or sensors respond to gas. It is an ATEX directive and records prove best practice is being followed and protects all parties from a legal perspective. If you don't have the records to prove it has been carried out, then it hasn't. How often do we need to bump test? As a manufacturer, JFG state a bump test should be carried out before and after an instrument has been used. Plus, a bump test should be carried out if the instrument is passed to another person to use. Typically, a bump test frequency alarm can be set in the instrument from 1 day to 365 days. How easy to bump test? The simple answer is very easy. A typical bump test should take no longer than 20 seconds. With ever-advancing technology in instrument and docking station design, increasing availability of gas mixtures, bump testing for many sensors is now possible. A manual bump test is also an option if the docking station is not available. There is no excuse not to bump test. The excuse is not to bump test? The H2S exposure myth. It is dangerous to use a cylinder that contains 25 ppm of H2S. Using a 34-litre cylinder in a 1,000 cubic metre room, if the entire cylinder was emptied, the concentration in the room would only be 0.03 ppm. There is no danger. It takes too long. On average, a bump test takes no longer than 20 seconds. It's expensive, too difficult, and training is required. Most docking stations are automatic and require minimal training on how to operate them. A less expensive option would be to bump test manually. There's no law saying we have to. It is an ATEX requirement. The laws are not clear, but they are written in such a manner to make bump function testing a requirement. After all, if something does go wrong, what would justify not bump testing to the authorities? There are no excuses not to bump test. What if a bump test fails? Most docking stations will notify the user that an instrument has failed a bump test. Manually, bump tested instruments will not indicate if a bump test has failed. Therefore, documented procedures must be adhered to. Do not use an instrument that has failed a bump test. How do you know if a bump test has passed or failed? Typically, an instrument will display a bump test failure warning. This warning will differ from manufacturer to manufacturer. Most docking stations record all tests, passes and failures and include certificate generation software.
A common method of testing gas detectors in the field is by using a pressurised canister of test gas, and its quality is crucial to reliable and accurate gas detection. Let's look at some characteristics of a gas mixture that affect its suitability. A supplier providing a calibration certificate is likely to be a more reliable source. This document includes information about the measured concentration of components in the mixture, how the measurements were made, and how accurate they are. Traceability is the property of those measurements whereby they're related through a chain of comparisons to international standards. you should be able to learn the traceability route for a test gas from its calibration certificate. Mixtures containing components like methane or hydrogen can feature shelf lives up to 5 years, but reactive components like H2S can have shorter stability periods. This is because they are more susceptible to chemical reaction, although a reliable supplier will be using advanced production techniques designed to prevent this. Do not use mixtures beyond their stated shelf life. The most common mode of supply of test gas is the non-refillable canister. The advantage is portability, enabling tests to be carried out in the field as well as in the workshop. They are easy to use because no tools are required to connect the gas control equipment, and generally there are no rental costs to consider, reducing the cost of having test gases on site. One common question is how many tests can be performed using each canister. The instrument manufacturer will normally recommend the optimum flow rate of gas needed in their operating procedures. Selecting a suitable fixed flow regulator, like this, will maximise the number of tests possible. Using a demand flow regulator like this for instruments fitted with internal pumps further optimises the process. These units limit the flow of gas to that demanded by the instrument and means there is no wasted gas. The largest canisters hold about 110 gas litres. So an instrument with a response time of 10 seconds using a fixed flow of gas of 1 litre per minute might be tested several hundred times using this type of canister. How can you ensure the same high quality gas from the canister reaches the instrument? It's important to consider the integrity of the system that delivers gas to the sensor. Every tube, joint and connection represents a potential leak point. So examples of good practice when making connections are listed here. Wherever there is a possibility of leakage, there's also a risk of air or moisture ingress, whereby the resulting dilution of components in the gas will reduce the initially known concentration. Some components can form corrosive aqueous solutions in the presence of atmospheric moisture, which may also interfere with the functioning of the instrument. Problems with corrosion, chemical reaction or absorption of mixture components are often the result of incompatibility of materials used in the sampling system. Ask your test gas supplier to recommend suitable gas control equipment. Finally, test gas mixtures produced at high pressure may lose their consistency when the canister is almost empty. The minimum usage pressure should be established from the calibration certificate, and the content should not be used once the pressure falls below that value. To sum up, 3 characteristics of a test gas are certification, traceability and stability. Select an appropriate test gas mixture for your instrument and work environment. The available modes of supply and the wide variety of gas control equipment available should allow ample flexibility for keeping suitable gas mixtures for bump testing in a safe and economical way.
The nature of our business means that we operate in potentially explosive atmospheres, and it's a core value of Gilbarco Veeder-Root that our associates work in a safe environment. All associates who come to work every day also go home every day. A failure of a gas monitor could put this value at risk and lead to a serious incident. It's the policy of Gilbarco Veeder-Root that all issued gas monitors must be tested at least every 30 days, but crucially prior to use. The test will then cover the usage of the monitor for that day only. The bump test must be recorded in the record book provided within the test kit. The record book, along with the proof of calibration, is subject to audit by Gilbarco Veeder-Root management and by customer representatives. The reason for this process is to verify that the device is functioning correctly when used. If the unit fails the test, do not use the device or undertake the activity requiring the use of the device. So, although the kit contains calibration gas, we are not calibrating the device, simply using the gas to trigger the sensors within the monitor. This is bump testing. The results of the test are to ensure that the device will activate an alarm when the sensors reach the set minimum activation levels. For this reason, the readings do not require to be recorded. It's important to ensure that your gas monitor is calibrated with the correct gas mixture for your application. At Gilbarco Veeder-Root, we use pentane as the LEL trigger instead of the more common methane because the characteristics are closer to the principal gas we expect to face during our work. At Gilbarco Veeder-Root, all associates who use a gas monitor in the course of their duties have had bump test training, which takes no more than 10 minutes, and the trainers have refresher training on a 3-year cycle. To conduct a manual bump test is very easy. First of all, switch on the device and ensure that all 4 sensors are recording correctly. That's 3 zeros and 20.9 for oxygen. Take your gas bottle out, check that your date is within calibration. Take your regulator, screw it onto the end of the gas bottle. Ensure you have gas reading. Take the clip and attach the clip to the device. Introduce gas slowly and check all 4 sensors are alarming. Once that's happened, turn the gas off, disconnect the clip and allow the monitor to clear. And finally, the most important part, take the bump test record book and record the bump test.
Thank you for watching the video. We hope you found it informative. For further information, please visit the websites shown at the end of this film.